Hello and welcome. In this lecture, we are going to be getting our tank to the stage where it can actually properly drive. Here's my tank. I'm able to drive it around. It's no longer rearing up off the ground because as soon as we start rearing up, we lose traction. We're only applying force when our wheel is on the ground. So that is making our tank much more stable and also means that it won't be able to fly. If I fly off the edge, I no longer am able to apply any sort of force whatsoever. So I just fall to my death. Great stuff. Let's dive in and see how that's going to happen because we're going to learn some interesting things about tick groups along the way. I'll see you in it. Okay, well, slipping around on the terrain is a lot of fun and we're able to kind of go and let me get focused in here. Yeah, we're able to move around, rear up like crazy, but it's not very tank-like. And part of the reason for this is that even when we lose traction with the ground, when our wheel comes off the ground, it's still applying a force, as you will see in a second when I go into a mad spin like this. So what we want to do is make sure that we are only applying this force when we are colliding. So if we have a look at our project, I'm going to go ahead and open up the source code for our sprung wheel CPP. Now what I'd like to do ideally is on hit we apply the force that we are adding to the driving force. But this does raise a slight problem. What happens if we don't hit the ground? How do we detect that we aren't hitting the ground if there's no collision? Well, let's have a little look. So, detecting no collision. So this is the arrow of time down here on the left. First of all, we get add driving force, a call coming in at somewhere near the beginning of the frame, telling us what force we should try and drive through the wheels. And that's going to add a force somewhere to some force variable that we're going to pick up on later. Then we might get an on-hit event. I put it in italics because we might not get an on-hit event. But if we do get an on-hit event, then we are going to apply that force to the wheel as we're currently doing always when we add a driving force. Okay, so that's going to apply a force to the wheel, which is then going to be picked up next frame rather than this frame, but hey-ho. And then what happens next? What we want to somehow have happen is that after the hit, after the possibility of a hit has finished, so we know that we won't be getting on hit if we haven't had one, we want to reset the force back to zero, cancel the force, so that the next frame around it is not having this cumulative effect of adding force on force on force, which we don't want, otherwise it's never going to slow down and it's always going to get faster and faster and faster. So this is the idea, but how do we find out what is after the hit? Well, the trick to this is understanding tick groups and their order. So let's have a little look at the documentation for tick groups. This is linked against your resources. So tick groups, they are something that you may not have come across before, but when we receive a tick in an actor or in a component, we could actually receive it at different times of the frame depending on what we specify. The default is something called pre-physics. So this means before any physics simulation happens. Basically, tick groups are mostly divided up about where they happen in relation to physics. Physics is going on in a separate thread, so we get all the state ready for physics, then physics simulation happens, and then the results of the simulation are available before the frame is rendered. That's the basic idea of a tick group. So what we end up with is these three major stages, which are the TG pre-physics, which happens before physics simulation even starts. Then we have during physics, at which point physics simulation has started, and we can do things in here that don't rely on the results of the physics simulation and don't require their inputs to go into the physics simulation. That can all happen in during physics. And then we have post-physics, at which point all the locations and positions have been updated that show where they've ended up after the physics calculation, but this is before we've actually rendered anything. And then after all of this happens, things get rendered to the screen and we start again from the pre-physics tick group. Okay, so the question here really is, when we're doing an on-hit event, which of these phases is it happening in? That's the question we want to answer. So first of all, let's go ahead and set up an on-hit event. So I'm going to do this from begin play. And I want to handle the on-hit event of the wheel. So we've got a setup constraint. Just before it, I'm going to do a wheel, arrow, on, component, and then I think it's on component or hit, is it? Let's see if we can find it. There we go, on component hit. Now, I can never remember the signature for these things, so let's F12 into there, jump to the definition of on component hit. You can also search for it in Visual Studio. Then we've got the type, which is on component hit signature. If we follow that link, then we see this is the declaration of the delegate. And what you need to look for is after the name of the delegate, everything else in here is the list of arguments for your on hit delegate. So I'm going to go ahead and copy those, go over to the the header file of the sprung wheel, and create an on hit function to handle it. So it's going to be in the private section, voids the return type, on hit is the name, and then we have got the arguments of said function. Now you'll notice they're a bit weird. Basically, there is a comma between the type and the name of the argument. This is basically because of the way that the macro works that is being used here to set up the dynamic delegate. Don't worry about it too much, just means you have to remove every other comma so that it actually is a valid argument list like so. That is because otherwise it would not be proper C++. Okay, so that's the on hit. And don't forget, this is a dynamic delegate, and I forget this all the time. And it's really horrible when it happens and you have to go and look for the log, and sometimes you're just wondering, why is this on hit not happening? It needs to be a U function. Okie doke. So then we're going to go ahead and implement our on hit. I'm going to go and implement it near the bottom of our C++ file. And then we're going to put the body in place like so. Great. So we've got an on hit function. We can put a log message in here to say that we're getting an on hit. So on hit. And I want to make sure I know which frame it's happening in. So let's do %f, and then I'm going to get the time, the global time from getWorld. So getWorld, arrow, get, and I think it should be time seconds, because autocomplete is not helping me out at the moment. So let's go ahead and build that, see if I got it right or if I got it wrong. But either way, that is vaguely what we want. Almost had it right. I've just missed the S off the end there. So there is other errors though in here, and I think it's particularly worried about the fact that I haven't finished this line in begin play registering our on hit event. So let's do that. We want a dynamic, add dynamic. Always autocomplete it incorrectly for me. So we then have to undo that. Anyway, I'm going to take the address of the on hit. In fact, first I've got to pass in this pointer to bind it to, then the address of a sprung wheel : on hit. And that's what we're linking up the dynamic delegate to. Now, one more thing we have to do is we have to make sure that the wheel is triggering the right events. Now, the way to do this is you can do it over in your blueprint, obviously, but when it's something that's required by the C++, I like to do it in the C++. So it's the uPrimitive component set notify rigid body collisions that you want that allows you to get on hit events. So we can just go ahead and set that to true via that function call. And I'm going to do it in begin play so that no matter what the default values are, we're always going to receive those on hit events and not be left confused. So, okay, that's going to give us a log message in on hit. But the question is, in tick, when is the tick happening? So let's do exactly the same thing. In fact, I'm going to copy over the code from on hit into tick. And I am going to just change the word on hit to tick without trying to overwrite things, like so. And if we go ahead and build that, we should get in the log messages an idea of what order things are currently happening in. So let's go ahead, we're in our Spring World, Spring Testbed. Let's go ahead and hit play. We can just stop right away. Oh no, we do have to hit the ground. Let's get close to the ground then. Get to the ground, hit the ground, get out of there, go to the output log, and there we go. We've got tick and on hit happening. And you can see here that the same timestamp is happening and then different timestamps. So we can determine that the order is first tick, then on hit. Obviously that's no good, so let's go ahead and have a look at what tick group we've got. So the way we can do that is by opening up our sprung wheel BP, going to the full blueprint, and then we want to have a look at the tick group that this actor is using. You can do this fairly straightforwardly. It's in the details pane right at the top when you've got the actor selected. There is the actor tick section, and you need to expand out to show the advanced settings. You can see there's the tick group, which is currently set to pre-physics, which is the default. Now, so obviously that is happening before physics. That's maybe why we're not getting our on hit event. Let's try during physics. Is that going to be any better? Let's go ahead and look at the output log, hit play, land on the ground, and it looks like the tick is still happening before on hit. Okay, so let's try post physics instead. What about post physics? And stop. Excellent. This time, it definitely looks like we're getting our on hit first, followed by post tick. So that seems to mean to me that on hit is getting called at the end of physics or during physics. And then we need to basically be resetting in our post tick. So that's quite useful. One way we can just solidify that we want post tick in here is two things. First of all, we can set the defaults in the constructor, so we can change it. It's part of the primary actor tick dot, and then it is the tick group we want to change. We can set the tick group to tg underscore post physics. There, it's auto completing for me. And what you can also do as a double safety check is in tick, you can just make sure that you're in the right tick group. So I can do an if get world, and then you can query the tick group from there. Tick group equals tg post physics, just so that we're not resetting things when we're not expecting to. I find that very helpful to do a double check in the tick like that. Okay, so armed with your new knowledge about tick groups, I would like you to apply the force on collision or reset it afterwards. So that's going to require a little bit of challenge time. So apply force on collision. That's what we're doing. So move the force handling to on hit rather than being directly where we're adding the force. Cancel the force before the next frame and test. Fairly straightforward challenge there. Let's pause the video and have a go. Okay, welcome back. So if we're going to be applying force, I don't just want to do it directly on tick. I want to make things a little bit more legible in my functions. So I'm going to create a new function called void apply force, like so. And it's going to be applying the force that is going to be in a variable. So we can go ahead and implement that over in the C++. And then it's a strung wheel, : apply force. Great. And then we are going to basically do the same code here from the add drive force in apply force instead. And its force magnitude is going to be, I'm going to change that to total force magnitude. And I've say this frame, just to be super clear what that means. Total force magnitude this frame, and it is going to be a variable on our sprungwheel.h. So let's go over to the header file and create a new float for the total force magnitude, which is going to default to 0 at the beginning. Okie doke. And then the total force magnitude, we're using it correctly, but in add driving force, we want to add to it. So I'm going to do a plus equals of the force magnitude, being sure to make it plus equals so that we are totting up the force. And that's quite important actually, because somewhere up here in the add movement component, we are, when we're doing an intend move forward and intend turn right, we are setting the throttle twice in a frame, and they are adding up together. So if we follow that down, the addition actually goes down all the way to the wheel. So we do need to be doing proper addition within the frame so that we get the total force magnitude at the end. You can try without and see what kind of weird stuff happens, but you won't be able to steer, is basically the gist. So we've got a total force magnitude this frame. We are going to do apply force. We're applying force when we're doing it on hit. So I'll remove the log message, and instead on hit, I'm going to apply the force. And finally, in tick, instead of logging out, when we've got our post physics group, what we're going to do is we're going to just reset our total force magnitude, because physics has been and gone. We have applied it via our on hit, and we can just reset it back to 0, ready for the next frame to populate. So let's go ahead and build and see if this is going to work as intended. Okay, well, the build succeeded at least. Let's go over to Unreal, have a look at our tank in the world, and try and move it. Okay, so here we are, and sure enough, it seems to be steering, it seems to be rotating on the spot all right, and crucially, is it still driving when we are in midair? So now we're on our backs, and we don't seem to be going anywhere, which is a good sign. Let's just try one more time, and then we'll try in the world itself. Oh dear, looks like I've got a bit of an error in my begin play. I'm not sure why that's happening. That's the tank player controller begin play. We can investigate that very, very quickly. So the tank player controller, CPP, begin play, what could have caused us to have a null pointer issue? Maybe get pawn in here could have had a null pointer issue. So let's just make sure that we're just doing a if not get pawn, then return. That could have been a problem. Let's go ahead and build that and open up the engine one more time and just give it a final test. Okay, so here we are in our main battle tank level. Let's go ahead and hit play and try and drive our tank around while focusing in the world. That would help. So here we are, very easily flipped over. Let me just fix that because that's to do with our center of gravity and also that our suspension is quite high. So let's go to the tank, sprung wheel, very, very quickly. And we're going to go to the viewport, select our axle, move it closer to the base of the tank. Let's go ahead and hit play, see if we're resting close to the ground. That's much better, much more stable. Okay, so you can see here now that I'm able to maneuver around pretty easily, actually. It seems to be working fairly nicely. I'm able to move around. That blast from the projectiles pretty crippling though, very hard to get anything done. So let's try it out in the spring test bed as well, just on this slope. Okay, so yeah, moving around. I'm moving around very nicely. Don't seem to be having any kind of glitching out issues. I'm able to turn on the spot. I'm able to accelerate. I'm able to accelerate a bit too much in my opinion. We'll have a look at fixing that. But mostly we have got our tank control issue under control. So let's just take a minute to summarize and soak in what we have learnt. So hopefully now you've got a good understanding of tick group order and how that interacts with physics notifications and physics in general. How we've got a pre-tick, a during physics, a pre-physics, a during physics, and then an after physics, and how physics is this asynchronous process that is happening in tandem with our preparation and our tick functions. So that's quite useful to know, and we've been able to apply that to get our driving to work only when we are touching the ground, which is basically improving the handling no end. It's much, much easier to drive the tank around. So big pats on the back. We are pretty much all the way there now. We're just going to do some things in the later lectures to tweak it up, make it a bit nicer, add more wheels, and hopefully add in a little bit of air resistance and maybe some resistance to rotation so that we can't go really, really fast turning corners or going really, really fast forward. So look forward to seeing you in the coming up lectures. See you there.